What if I told you there's a computer that can solve problems which today's fastest computer would take millions of years to solve? This computer already exists. It is called quantum computing. Hi everyone, my name is Nishant. Welcome to my channel. Today I will explain what quantum computing is, how it works, and why it is so powerful. So let's start. So what is quantum computing? So quantum computing is a new way of processing information using the principle of quantum physics. Unlike classical computer which process the information step by step, quantum computers can evaluate many possibilities at the same time, allowing them to solve certain problems more efficiently. What is classical computer? So all the computers that we use today are called classical computers. They operate on bits. A bit can have only one value at a time, either 0 or 1. Because of this limitation, a classical computer processes problems sequentially, checking one possibility after another. What is quantum computers? So quantum computers are using qubits instead of bits. A qubit is fundamentally different because it can represent 0, 1 or combination of both. This property enables the quantum computers to explore multiple solutions simultaneously, which is the foundation of the computational advantage in the case of quantum computers. Now, these quantum computers basically based on two fundamental things. One is called superposition and other is called the entanglement. So let's talk one by one. What is superposition? So superposition is one of the core principles of quantum computing. In classical system, information must be in a single and definite state. In contrast, a qubit superposition can exist in multiple states at the same time. An easy way to visualize this is with a coin. A classical bit is like a coin lying flat on a table, either showing head or tail. A qubit in superposition is like a coin spinning in the air. While it is spinning, it represents both states simultaneously. Because of the superposition, a quantum computer can work with many potential solutions at once. This allows the systems to evaluate a vast solution space in parallel, powerful for optimization and simulation problems. Now the fundamental property is entanglement. So what is entanglement? So entanglement is another uniquely quantum phenomenon that gives the quantum computer their strength. When two or more qubits become entangled, the states are no longer independent. This means that measuring or changing state of one qubit instantly affects the state of other, even if the qubits are separated by large distances. This behavior has no equivalent in the classical computing. Entanglement allows the quantum computers to operate as deeply as connected systems. Qubits work together rather independently, enabling the complex correlation and computations that classical computers cannot efficiently reproduce. So why we are talking today about the quantum computers? Why does it so matter? Why does it matter? So quantum computer matters because it can solve problems that are computationally infeasible for classical computers. This include drug discovery, financial optimization, cryptography, artificial intelligence, and large-scale scientific simulations. Where do we stand in terms of quantum computing today? So today quantum computers are still in an experimental stage. They are powerful but sensitive to noise and the environmental disturbances. Despite the challenges, rapid progress is being made worldwide. The future of quantum computing. So quantum computing represents the next major evolution in the computing technology. Although we are still in the development, long-term impact will be transformative. Understanding the quantum computing today prepares us for the technology tomorrow. So like, subscribe and comment if you want more videos on quantum computing.